In this simulation, we're modeling a continuous stirred tank reactor that carries out an adiabatic reaction. It's set up that you can choose among 3 exothermic reactions, and you can control the inlet feed concentration, and you can control the volumetric flow rate. So that essentially controls then the residence time. You've increased the volumetric flow rate, less time for reaction. And the simulation calculates the outlet temperature and the outlet reactant concentration. So A is the limiting reactant, which for the reaction shown will be ethyl acetate. Sodium hydroxide is in excess. Well, the simulation is set up that the colors approximately correspond to how high the temperature is. So low temperature, 6 degrees, is blue. As the temperature increases, the colors become purple, more purple, and then they become red at the highest temperature. So the simulation also displays the fractional conversion, XA. In this case, 93% of that limiting reactant A has reacted to product. So let's look at the interactive simulation. So here's the interactive simulation. So you can see if I increase the concentration of the limiting reactant in the feed, then the outlet temperature increases as I get more reaction. Likewise, if I decrease the flow rate, so there's a longer residence time, then the outlet temperature also increases. Adiabatic reactor, and now of course we've converted 94%, so if we keep decreasing the volumetric flow rate, I'll get a higher temperature. Well, this simulation has 3 possible reactions. If I select this reaction, heat reaction is higher. You can say the outlet and the reactor is now red. Of course, the outlet temperature is the same temperature as the reactor temperature. In this case, the conversion is essentially 100%. I can increase the volumetric flow rate, lower the concentration, and now get a much smaller conversion, therefore a much smaller temperature increase. So hopefully this adiabatic CSTR gives you some better understanding of behavior. In a CSTR where we have a drop in concentration of reactant to the final value, so the concentration leaving is the same as the concentration in reactor, the temperature leaving is the same as the temperature in the reactor.